Hey, this is a short video I'm recording between lecture 3 and 4. We fell behind a little bit in lecture 3 today, so I wanted to try and catch us up by recording the rest of that lecture and posting it online for you to watch. In class, we were using GDB and having a look at Git, and we got as far as running GDB on 3 broken versions of this prime program, and we fixed them all and pushed our changes up to our remote repo. I wanted to show you one more thing you can do with GDB. We talked about it, but we didn't try out the text user interface. If you run GDB and you use the -TUI option, and then the rest of it you can run as normal. So let's run it on this first primes program. This is one that we've already fixed. With TUI, it tries to build what it calls a text user interface. So it tries to draw using the terminal, what you might normally get in an IDE if you were running a debugger. So it's got a message down here. If I hit enter, it'll go ahead and finish drawing the user interface. You can see it's got my source code up here in the top part of my terminal, and down at the bottom I can type normal GDB commands. So let's try this a little bit. Let's run GDB, or sorry, let's set a breakpoint. So let's set a breakpoint at the start of main, break main. And then when we run the program, it'll stop right away. You can see up in the text user interface part, it's trying to show that I've got a breakpoint set. That's not the word main, but it's the first real line of code in the main function. So that's where it's going to stop. Let's go ahead and run it. And you can see right away it stops on the first iteration of this for loop. If we step through the loop a little bit, you can see it's highlighting the line of code that I'm running. And every time I hit enter, it's just rerunning the next command. So it's single stepping through each of my statements. You can see over here on the left, this 3 is really the output of the program. I mentioned in class that when your program starts generating terminal output, sometimes that'll mess up the interface for TUI, for the text user interface. If that happens, like here, this 3 isn't too much of a problem, but if it kind of messed up what I was seeing in this text part or in the command part, if you type Control L, hold Control and press L, it'll repaint the user interface. And you can see that overwrote this and made the 3 go away. Here we're single stepping through the code a little bit. Remember, we can use print or P to print out the value of a variable, like we're on our third iteration, so I is up to 4. We're about to call this isPrime function, and if we use the step command instead of the next command, it'll go into that function call rather than just stepping over it. So let's try step, or abbreviate it as S. So this will go into the isPrime function, and then we can step through the statements there. Remember, when you're in a function, I mentioned you can type finish, and this will run. It's like continue, but instead of running to the next breakpoint, it'll run until it exits the function. So finish will go down to the bottom, and you can see it says you finish the function, and it returned false because 4 isn't prime, so it won't print that out. So there, it skips ahead to the next iteration of the loop. I just wanted to show these few additional commands and the text user interface. So let's quit GDB and let's talk about Git a little bit more. Let's go back to our slides and take a look at kind of a summary of GDB. In class, we talked about commands and we kind of looked at them one at a time. I put what I thought were the most useful commands in a few tables here in the slides. We won't go through all of these again, but if you need to remind yourself of a command or its abbreviation, this is probably an easier way to look these up rather than watching through the video again, or even those earlier slides. So setting breakpoints, running a program and continuing, single stepping through a program, and finishing, running ahead to a particular line number or finishing a function. These are commands for looking at or changing the state of your program, like looking at your source code or looking at a variable. And these are kind of miscellaneous commands for looking at a stack trace or moving around within a stack trace. One thing we didn't get to talk about is conditional breakpoints. You can see I've listed that here. That's a handy feature for setting a breakpoint that only fires when a particular condition is met. That's a nice way of trying to run ahead in your program until you get to the part you want to debug. We won't go over that in class, but it's a thing you can look up if you feel like you need something like that. That gets us through talking about talking about GDB. We've just got a little bit left to talk about Git. You remember we ran the git status command and it reported, we already did this in class, it reported the files we had changed and new files that weren't in our repo. You'll notice it's ignoring some files. We compiled each of these programs, so we had an executable for primes 1, 2, and 3, but it doesn't say anything about those. And the reason, sorry, let me run ahead. The reason is because you can have a .gitignore file, and that lets you mark certain files or certain kinds of files for Git to ignore. So it doesn't report on them when you do git status. It doesn't commit them to your repo. That makes it easy to mark certain files so you can't accidentally commit them to a repo. There's some files that are just temporary files and you wouldn't want them under revision control. The repos we made for you have a top-level git ignore file that ignores things like object files. For each of our projects, we'll have a separate git ignore file that we'll use to mark files specific to that project that don't need to go into the repo. Backing up a little bit, just going through what we did in class, we looked at what had been modified. We added our changed files to the repo. And what this really does, or the right way to say this, is it stages them for the next commit. It puts those versions of those files in what's called the index. And that's the set of changes, or really the set of changed files that are going to go into the next commit that are really what's changing in the next version of the repo. So adding our files, staged them in the index. If we did a git status then, and we did this in class, it reports what's going to go into the next commit. We just talked about git ignore. And then when you do git commit, that puts a new version of all of the staged files in your local repository. When we did this in class, it brought up a text editor and it expected us to type a message in the text editor. Or like we did in class, you can specify a message with -m and then you don't have to type it into an editor, especially one that you might not be comfortable with. There's also another option, and these usually get combined. -a on a commit says to automatically add files that are tracked. It won't put new files in your repo. If you created a new file, you still have to add that separately. But if you've already got files that are being tracked, files that you've previously added, and you've just modified them, -a will automatically put any of those modified files into the next commit. So usually this means once you get started on a project, as long as you're not adding anything new to it, you can just use the -am option to commit and comment on each change as you commit it. We did this in class. We saw that just committing our files isn't enough to get their changes up to NCSU's GitHub. That means that changes won't be seen for grading unless you do a push. The last thing we did, I think, was a git push. And that, like my picture tries to show at the bottom, that takes any new revisions in your local repository and copies them up to the remote repository. Since we cloned this repo from NCSU's GitHub, that's where those changes get pushed up to. If changes get made to your repo from somewhere else and you want to pull those down, the pull command does copies changes the other way. It copies changes from a remote repo down to your local repo. So this would make sense. This would be something you'd want to do if you were working from multiple copies of your repo. You could work on one copy for a while, commit all of your changes, push them up to NCSU's GitHub. And then if you went to another cloned copy of repo, you'd want to pull down those changes before you started working on that copy. Because if you didn't pull down those changes, they'd be the copy you were working on would be out of date. And that's what I want to show next. Let's go back to our example. I've got a copy of my repo right here. It's the same one we were just working with. And I can also get to my repo here from the web interface. This is just like we were looking at in class. If I pick this primes1.c, I can see the source code, and I can even make edits right here. If I click on this little pencil icon, it'll bring me up into an editor, and I can go in and change this source code. Like maybe I can change this limit. This controls how many primes are generated, or how many values are checked for primeness. So instead of looking at values 2 to 100, let's look at 2 to 500. Here I'm just editing this file, but still changes I make need to get committed to my repo in order for them to be visible to anyone else. From the web interface, I can do that down here at the bottom. In fact, it gives you a default comment for the change. Let's make our own comment. Let's say more primes. And then when we hit commit, just the changes to this one file will go in as our modification. Just this one line of change will go in to our new revision. Meanwhile, if we go back to our terminal window, I've still got my own local copy of these files. And if we take a look at primes1.c, you can see we don't see the change there. If we wanted to, we would have to do the pull command that we were just talking about. And then it would pull down that one new revision we just made through the web interface, and we'd see 500 here. Instead, let's cause a problem. Let's go in and change here. Let's change this to, instead of 100, let's make it 10,000. So really, I just made a conflicting change to this file. Here in my local repo, I haven't committed this change yet, so I don't really have a revision for it. But let's go ahead and do that. Let's pretend I was working on this copy and I made a change. And let's pretend I didn't know that I had this conflicting change right here that I had made somewhere else. Here I did it through the web interface, but the same thing would happen if someone else changed that file through their own cloned copy of your repo. So let's go here, let's commit the change we just made. If we do a git status, you can see it knows that file's been modified. This would be a good chance to use that git commit -am. So the add means, or the -a means, it'll automatically commit the latest change to any tracked files. So it'll commit this without me having to add it separately. And let's go ahead and have a comment. Let's say way more primes. Now it's committed. Oops. Oh, sorry. The exclamation mark is a special character to the shell. And even the double quotes there are not enough to, so it's not enough to suppress its special interpretation. So it didn't do this command. Let's try again, and we'll just downgrade that to a period. All right, so our new change is committed. But now I've got a revision here locally that has one change, and a revision here that I made through the web interface that's a different change. Let's try and do a push. So git push, that's what I would normally do. I have to type my password, but it's not going to like it because it tried to push my changes, but there's a conflicting change remotely. What I have to do to fix this is I have to pull that remote change down locally, and I have to decide how to resolve those conflicting changes. And you can see it gives you a hint of how you can proceed. It says you're going to have to do a git pull, and you're going to have to figure out how to resolve these conflicting edits. So let's do our git pull. It's making me type my password every time. That's because logged in remotely on a common platform machine, it's not remembering my password. Other systems can remember your password, so you don't have to type this over and over again. And how I normally work lets me do that. All right, there goes my password. It pulled it down a copy, but you can see it says there's a conflict in this file. And if we take a look at that file, let's look at primes1.c. Yeah, right here is the conflict. And you can see it added extra stuff to this file to show me what's the two lines that disagree. Here's my line that I just made locally. And here's the one it got in the revision that it just pulled down. And the rest of this is just extra decoration so that you can tell what's what. To resolve this conflict, it's my job to decide what this code should look like. I can edit it just like I normally would. And in this editor, I can delete these extra lines. Now, these are the two conflicting lines. It wouldn't make sense to keep both of them. Let's go with a compromise line. I don't know if this is really a compromise, but maybe a limit of 2,000 is a compromise between those two limits. If this was, in a more typical conflict, you might have to write code that resolved the two, that worked for both of the changes that you were trying to reconcile. Here, we'll just pick a value for that constant that's kind of partway in between. And then if I do a write, even making that agreement between the two edits, that's another revision, and I need to commit that. So if I do a git commit -a, this will do one more commit, and you can think of it as the change that made those two files agree. Here, well, I didn't give it a message, but I knew it was going to give me a default message. So it's smart enough to remember, oh, you're making this last commit or this commit to merge these two conflicting edits to the file. So I don't really need to change that. In this editor, I can just do a :WQ for little q for write and quit, and that'll save it. And then finally, that change, git status, got pushed. It's still not up at the remote repo, but now I can do a push. So sorry, I said it got pushed here. It got committed. If I do a push, git push, then that last change, once I type my password, that last change will get pushed up to NCSU's GitHub. And now if we go back to the web interface and we refresh, you can see that's the version that I committed. So it took a couple of steps. If you change or if you access your repo from a few different cloned copies, this is the kind of thing you'll want to keep in mind. If you switch from one cloned copy to another, and you always do a push when you start working, you shouldn't have conflicts like this with just one developer working on a repo. But in the real world, when multiple developers are working on a repo, this is the kind of thing you have to consider all the time, the possibility of two different people editing the same thing. That should get us through most of our material. Let's catch up in the slides. So we did this. We generated a conflicting edit. This is the kind of message we saw a moment ago. This is, I mean, it's not the same values, but it's the same thing we did. We resolved a conflict. And then we did these three things. We didn't really add, we used the -a option, but we committed the resolved edit, and then we pushed it. Then we were able to push it up to NCSU's GitHub. If you look at the style guide, it talks about keeping a clean repo as one of the things that you'll be graded on. So the point is you don't want a bunch of extra garbage temporary files in your repo. You should really, in your repo, you should only have things that are relevant to your project and that you might need to build a new version of your executable or maybe to test it. that's a good thing to try to do, but still I understand mistakes will get made and you'll probably accidentally commit something that you didn't mean to. Using git status can help you avoid that, but if you accidentally commit something that doesn't belong in your repo, it's easy to get rid of, but you can't do it just by deleting the file in your own local copy. Removing something is just one other change to your repo, and you have to remove it and then commit that change. So to remove something, you have to tell Git that you want to remove it. And here's the command for doing that. If you say git rm, and then any file you want to remove, it'll remove that file locally. So you should see the file go away. But it'll also stage that removal as part of the next commit. So after you do this remove, if there are any other changes you want to make, you can go ahead and make those. And then the next commit you do will commit the removal of that file. And then the next push you do should make that file go away from NCSU's GitHub. I think I already mentioned, starting with project 2, we'll be using NCSU's GitHub. You've already got a repo, probably you've been using it to work along with these examples. Starting with that, committing your repo is how we'll grade your project. The workflow you'll normally use is you'll clone your repo somewhere, probably early in the semester, as soon as you start working on project 2. And then whenever you work on a project, you'll probably do a git pull to get any changes that might have gone into your repo, maybe from another clone copy. And then you'll edit files that you need to change. Maybe you'll try compiling and running some tests. Eventually, once you've made some changes, you can add any new files that need to get added to your repo. That'll stage them for the next commit. And then when you do a get commit, if you've also made changes to files that are already tracked, you can use this -A option. You can use the -M option to avoid, just to give the message for the next commit right there on the command line. And you could potentially do that over and over again. But once you're editing, adding new files, committing your changes, and then once you've got changes that are worth letting someone else see, you can do a git push, and that'll push them up to NCSU's repo. I would suggest whenever you make worthwhile changes to your project, I'd go ahead and push them. And that shows the progress that you're making on the project. Sometimes for various reasons, we like to go see the progress people are making on their projects. So it's always worth it to kind of show that you're working on your project if you are working on your project. So don't be hesitant about pushing changes, especially if they're improvements to your project. And that gets us caught up. I'm sorry to have to record something outside class, but hopefully this will let us start right at the start of lecture 4 on Thursday. That's all for now. I'll see you on Thursday.